So let's talk about these two things: explicit form, implicit form of functions. Here's an example of a function let's be more specific, a function of x expressed explicitly. Ooh, if I can spell explicitly, there we go. Y equals 3x squared minus 5. That's a function that's expressed explicitly. Isn't that what we're used to seeing?
Yeah.
We've seen a whole bunch of these. I'm not talking about the quadratic. I'm talking about y is by itself on one side, and everything else on the other side is in terms of x. Y equals some expression in terms of x. You follow? Okay. A function that's defined implicitly. A function of x expressed implicitly would be something like x times y equals 1. Now sometimes it's pretty easy to rearrange a few things to write it explicitly, but if we just left it like that, x times y equals 1, that would be considered the implicit form. It's a function of x expressed implicitly. How do we describe the difference? Using our own words, how would we describe the difference in those two functions? X and y are on the same side. Y is not by itself. It's a function of x. Still, it's a function of x, but x and y are on the same side. Again, this one's pretty easy to move the divide by x. You get y equals 1 over x. Sometimes not quite as easy. If we get a function that's defined implicitly, and we can't rearrange things to get y by itself, then we have to take the derivative using what's called implicit differentiation at that point. Okay. Do you understand where we're going with this? Yeah.
Would it be in explicit form if it was like 3y equals 9x squared minus 15?
No, it has to be x's and y's on one side.
Well, like y has to be above.
Yeah.
Okay.
So let's talk about what implicit differentiation is. Implicit differentiation, all it is, it's a form of the chain rule. So before we actually get into an implicit function, let's just look at an expression. So this is not an equation, this is just an expression. Let's look at 3y squared. How do we know that's not an equation? I want to be sure you understand what I'm saying. Why is that not an equation? There's no equal sign, it's just an expression. Okay? The problem here, and I know we're still early in calculus, but the symbols, what does that mean? With respect to what, though? That says take the derivative with respect to x. But there is no x, right? So please write down and try to consider everything I'm saying. We need to consider y not just as a variable that represents a number. We think of y represents a function in terms of x. So y does not represent a number. Y represents a function in terms of x. So I know it says a y right here, but y is just a substitution for some kind of an expression in terms of x, like 2x minus 1, or x plus 5, or something like that. Yeah?
So this expression will be different from one another?
Yeah, this is just some random expression. So if we did a chain rule, we have an outer function and we have an inner function. Okay? The outer function is 3y squared. The inner function is whatever y represents. Y represents some kind of a function in terms of x. You following me? So if we wanted to take this derivative, we do the derivative of the outer function first, which is going to be 6y. But now we have to take the derivative of the inner function. So dy, in terms of what though? What are we taking the derivative in terms of? Of x, right?
I want to make sure we're clear on what happened here. Where did the 6y come from? That's the derivative of the outer function, right? You just drop the 2 down and then decrease the power by 1. Now what's with the dy dx?
That's the chain rule part of this. This right here was the derivative of the outer function. This is the derivative of the inner function. The inner function was y. And what's the derivative of y with respect to x? dy over dx. That's the derivative of y with respect to x. Okay? So implicit differentiation, all it really is a chain rule. You have an outer function, then you have an inner function, y, so you have to take the derivative of y with respect to x. Okay? So this one here then. What if we had, I don't know, something similar, 2y to the 4th plus y squared. If I wanted to take the derivative of the whole thing with respect to x, again, this is not an implicitly expressed function. This is just an expression because there's no equal sign. There's a plus sign, so we can take the derivative of each separately. Isn't that one of the rules of differentiation we learned about? So all we need to do is dx of 2y to the 4th plus the derivative with respect to x of y squared. We just take them separately because there's a plus sign between them.
And then would you still use a chain rule?
We still use a chain rule. Now,
I want you to be clear on why we're using chain rule. What are we taking the derivative with respect to? X. But what do we have here? We have y. If the variables don't match, that's implicit differentiation, and you have to use a chain rule.
okay? Yeah.
So, on like a homework problem or a test, are they going to give you like an equation for y? Or
Yeah, we're getting to that. Yeah, we're getting to that. So let's deal with this first part. 2y to the 4th. What's the derivative of that? 8y to the 3rd. That's the derivative of the outer function.
Plus
Now we have to do the derivative of the inner function, dy dx. Okay. Plus, now we do the derivative. This is 2y times the derivative of the inner function, dy dx. Okay. If something's not clicking or if something's not making sense, we gotta ask questions. Why do we have dy dx here and in here? What is dy dx?
So this is just satisfied the equation. So when you put dy in, you find the function of y respect to x. So that how you do is when you find what y is, the function of y, then you just plug that in.
Let's say that again. We don't know what function y represents. Y just represents some function of x.
So you leave it like that because you have no way of knowing unless they give it to you.
True.
Unless you find out. Yeah, for the function of x.
Yep. But that's why we have to take the derivative of y with respect to x.
Yeah.
Because it's the chain rule part. So we do the derivative of the outer function here times the derivative of the inner function here. Yeah.
But you can't go any further than that without writing the equation that y.
what you're eventually going to have to do is collect the dy dx's together. This one has a dy dx, and that one has a dy dx, right? So eventually you're going to have to factor out the dy dx. That would equal 8y to the third plus 2y. I know you could factor out a y as well, but for what we're going to do soon, you're only going to want to factor out a dy dx. Okay? So let's get into some actual equations now, defined implicitly. Actually, wait, one more before we get into an equation. What about this one? Ooh, this one's dang tricky. Xy squared, derivative with respect to x of xy squared. So, what do you think?
Do it the same way, but use the product rule.
Product rule. Because it's x times y squared. So this is a product rule. Okay? So we need to think, all right, the product rule says f prime of x, g of x, plus g prime of x, f of x. That's the product rule. And the whole time we're taking the derivative with respect to x. Now, if we're taking the derivative of with respect to x of something defined in x, there's no chain rule part.
So they give you x equals this.
Well, for example, f prime of x times g of x, if we're considering this to be f of x here and this is g of x, then what's the derivative with respect to x of x? It's just 1. We don't need to have a dy dx because there wasn't any y associated with that part of the function. You guys follow?
Yeah.
And now we multiply that by g of x, which is y squared. Okay. Now we add g prime of x. So the derivative of this piece, y squared, the derivative is 2y. But we're taking the derivative still with respect to x, so it's not just 2y, it's 2y dy dx times the f function, which is x. So then this is y squared plus 2xy dy dx.
And you can't factor out the y.
You can't factor, you could, but what we really go for is if both sides have a dy dx, then you factor that out. Right? So let's get into an actual function. So here's a new example. An implicitly defined function. So now this is going to have an equal sign. Y to the third plus y squared minus 5y minus x squared equals -4. This is defined implicitly because we have x's and y's on the same side, and there is a way we could try to get y by itself, but it's dang hard. So we're just going to leave it like it is defined implicitly. Yeah.
So that's what implicit means with x and y are on the same.
Yeah, we're on the same side. Okay? And we're supposed to find dy dx. Okay? So let's just keep a little teeny list of steps. Step 1 is to differentiate both sides with respect to x. Differentiate both sides with respect. Both sides of what? Both sides of what? of the equation. So let's do that. So this side needs to be differentiated with respect to x. This side over here, we need to find the derivative with respect to x. Let's start on the right side. That's the easy part. What's the derivative of negative 4? 0. The derivative of a constant is 0.
So do we have to do the addition, subtraction?
Yeah. Yeah.
Could you like add x squared to both sides so that you have like all the y's on one side and all the x?
Before doing this, yeah, you could have.
Four? Yeah, okay.
You could have.
Okay.
But since we're taking the derivative of the sum or difference of individual terms, just take the derivative of the individual terms with respect to x. So what's the derivative of y cubed? 3y squared dy dx. That's the derivative of the first term there. Plus 2y dy dx. Minus 5 dy dx. So that's the derivative of that. That's the derivative of that. Equals 0. Now the derivative of negative x squared is negative 2x. Does that one need a dy dx?
No.
There's no y there. Yeah. Yeah, that's what the next step. Did you have a question, Parker?
Yeah, what do you put the dy over dx?
Because we're taking the derivative of these, but with respect to x. So this is a chain rule. So you got to imagine that y isn't really y. It's like an inner function. So you would drop down the 3 here and get 3, and then that changes to 2, right? But now we have to do the derivative of the inner function. And what is the inner function?
We don't know.
We don't know, but we call it y. And what's the derivative of y with respect to x? It's dy dx.
So if you didn't know what y was, you don't have to do dy dx.
If we knew what y was, we would replace all the y's, and then we'd have everything in terms of x. So that we wouldn't need implicit differentiation in that one. Does that make sense? Did I answer your question, Parker?
I think so.
Okay.
Would it be easier though, like if you did have the y equation to solve it all using the dy dx, and then at the end have to factor out the dy dx? Put in the equation and solve it?
It might be, but we're never ever going to know what y equals. So the second step, I think Jessica already said it, the second step is to collect all terms with dy dx on the left side. Step 3 is to factor out the dy dx. So let's do those two steps there. Everything that has a dy dx needs to be on the left side. Everything else that doesn't has to be on the right side. So there's really one thing to do there. We add the 2x over. So we have, now just to save time, we're going to be okay combining steps 2 and 3 into 1. If we move the 2x over and then factored out a dy dx from all of these terms, then we're going to have dy dx parenthesis equals 2x. And what's in the parenthesis?
3y squared plus 2y minus 5.
Okay. I know I'm going a little bit quicker, but we okay so far?
Yeah.
Step 4, last step. What is it we were supposed to find? You guys can tell me the fourth step. We're supposed to find dy dx means solve for dy dx. So how do we solve what we have now for dy dx?
Divide by 3y.
Yeah, divide by that parenthesis expression. So step 4 is to isolate your single dy dx. In this case, you would divide. So dy dx equals 2x over 3y squared plus 2y minus 5.
So that's the function.
That's the derivative. This was the original function right here. Well, what was it? Y, I erased part of it. What did it start with? Y to the third? So this was the original function, the one in red. This right here is the derivative of that function, dy dx. Okay.
So we pretty much just solve for the derivative without the function.
We had the function, we just didn't have it in terms of y equals. She read my mind. I was just going to ask. What else am I thinking about? Close. I was thinking about Carl's Jr., but it's still food. So he brought up a pretty good point that I was just going to ask you guys. You listening? One of the things we learned about 3 weeks ago, what's the derivative even good for? The slope of a tangent line. Right? What if the question had said, all right, here's your equation, y to the third plus y squared minus 2y. What if they gave you the equation and it asked for the slope of a tangent line at like 2, 5? You'd plug in a 2 for x, and then you'd plug in a 5 for y. And then what would you have? The slope of a tangent line. Okay? So you can still use this to find the slope of a tangent line at any given point by plugging in the x and the y. Okay? Yeah. No, this is the only way.
Thank you. Or if you have the TI-89.
Or if you have a TI-89. Did you try this, Zane? Are you? Let's try another one.
Zane uses the TI-89 on all the tests.
So you would type in the original, but with respect to x. Oh, I wanted to show you guys something. This is kind of off topic. I want to show you a cool little website. Check it out. Write this down. Hey, shut the mouse.
Best thing ever.
This website, Wolfram Alpha, like if you're doing homework and you get a little stuck, this is a pretty cool website. Because you can, it's free. Not the full thing, but you can type in anything you want into this bar and it will solve it for you. It'll graph it for you, it'll take the derivative, anything.
Type it in.
So if we type in y to the third, what was it, plus
Y to the second.
y to the second
Minus 5y.
minus 5y minus x squared equals -4, and then derivative it's thinking
Whoa.
so
Alternate form.
it says y prime, but y prime is dy dx.
Third derivative.
So now it's assuming with respect to x, because I didn't tell it, the default is always with respect to x.
It's just a kind of a way if you're doing your homework, and
It'll also do the step-by-step solution.
if you subscribe,
If you subscribe, which I think is worth it if you really just want to help. So it'll tell you exactly how to do it.
I don't think it's that much to subscribe, but it'll tell you exactly, here's step 1, here's step 2, here's step 3. It's pretty cool.
How much does it cost?
I don't know. But
Like you're selling so many.
anyway, it's called Wolfram Alpha. It's a pretty cool little website.
Solve every problem. You just have to subscribe.
Let's try another one. Determine the slope of the tangent line of the graph x squared plus 4y squared equals 4 at the point square root of 2 comma -1 over square root of 2
that be such a weird coordinate?
Yeah, why don't you use this tool supposed to help?
Can't it be just 2 to 1 or something like that?
Some of you probably, but not all of you.
Like to me, I hate Braden.
No.
Braden's a know-it-all. What's it like, Braden? Know-it-all.
I'll have to come back and take a look at that.
Had to be visual.
So, we got to speed this up. Here we go. We have to take the derivative of the whole thing with respect to x. Stay with me here. Starting on the right side, the derivative of 4 is 0. What's the derivative of x squared with respect to x? Is it just 2x or is it 2x dy? Do we need, what is it? Just 2x. There's no y's here. Plus 8y dy dx.
Subtract 2x.
That was step 1. Step 1 is to take the derivative. Step 2 is to get everything with the dy dx on the left side. So, what were you saying, Dan?
Subtract 2x.
Minus 2x over. So we're going to have 8y dy dx equals negative 2x. Divide by 8y. So dy dx equals negative 2x over 8y. Well, let's simplify that a tiny bit more. Negative x over 4y so this is the derivative right here. Among other things, one of the uses of a derivative is to find the slope of a tangent line, as long as we know the coordinates of a point. And we know the coordinates of a point. So now you plug in those values. So it's negative square root of 2 over come on, keep going. Divided by 4 times negative 1 over root 2. But this is negative square root of 2. Excuse me. Divided by negative 4 over root 2. So you can multiply by the reciprocal, negative square root of 2 over 4.
Hey, how did you solve it, Gabe?
The square root of 2 times the square root of 2 is just, you guys know this, square root of 2 times square root of 2 is 2. So this is 2 over 4, which is 1/2. The slope of the tangent line at that point is 1/2. Okay. We are running short. We got to do one more real quick. Last example, and we're going to apply find dy dx, and the function is 3 times quantity x squared plus y squared squared equals 100 xy.
Yeah. You did it the same way as Mr. Hunt just did it. Just didn't simplify before you did it.
No, Jesus.
That's awesome.
What's step 1? Differentiate. We're losing a little bit of focus, and that can't happen on this problem. It's a tough one.
Uh-oh, it's Brandon. Sit down.
We have to find the derivative here with respect to x, and we have to find the derivative here
So we use the chain rule on the other side.
with respect to x. Let's start on the right. Yeah, the left side is going to involve a chain. Let's start on the right side.
Um, 100x times y.
This is a product rule, you guys. It's 10x times y. It's a product rule.
100x.
Or 100x, yeah. So, if we're just doing the derivative of this, 100x times y, that's a product rule. And we're going to call 100x the f function, and y is the g function. So what's f prime times g?
So it's 100.
100 times y plus 100x dy dx.
Yeah.
Okay, hold on. We're going a little quick here. Hold on. Let's start back here.
You said 10.
But I'm a little concerned that we're not following. It doesn't make sense to plow through if nobody's with me. The 100y, where'd the x go? That's the derivative. The derivative of 100x is 100, and then times y. Now, this part here, this is f of x. This is g prime of x, right?
Yeah.
And the g function was y. What's the derivative of y? dy dx. Okay? Yeah, if it's with respect to x.
We ever done a derivative with respect to
If we did the derivative with respect to y, the derivative of y would just be 1. Okay, thank you. Okay, you guys, on the left side, this is a chain rule. Drop down the 2. So we have 6 times x squared plus y squared. That power decreases by 1. So it's just to the first power. But now we need to multiply that by the derivative of the inner function with respect to y. So that's going to be 2x plus 2y dy dx. Yeah, I guess double chain rule, yeah. Okay, we're almost done. This right here, that has to move over to the other side. How come?
Because it has a dy dx.
It's got a dy dx. Okay? And then somehow all of this other stuff has to move over to this that doesn't have a dy dx.
Yeah.
Okay?
Would you divide by the 6? The 6x squared.
Okay. We're not going to have time to finish this problem, you guys. We're going to have to, I know it sucks, we're going to have to stop it right here. The bell's going to ring. So we're going to have to pick this up. When do I see you guys next? Monday.